So today we're going to talk about building achievable application with Flux. Again, thanks for coming out early on Saturday morning. Just for starters, let me introduce myself. I'm Nick Tomlin. I'm a front-end dev at Braintree in Chicago, where I write JavaScript on the client and the server. Occasionally, I pretend to write poetry, and it's pretty bad. And just as an aside, Braintree is hiring across the stack in SF and Chicago, and we do remote work. So if that interests you, if any of those things interest you, please let me know. I'd love to talk about them. So I'll start asking some questions. The first of which is, what is Flux? The long and short of it is that it's an architecture for client-side applications, created and used by Facebook, Yahoo, and some others. And it's a philosophy, not a framework. So I think that's important to note. Is we'll see some implementations today. One that I've sort of made, which is using kind of Facebook's default, the one you'll get from their tutorials. But there are many others out there. People have used it, like as this gentleman was saying earlier, in different languages, across different stacks. So there's many different tweaks and interpretations of what Flux is in the real world. So bear that in mind. I guess a good question is, why would you be interested in using Flux for your application? And this image might be a good reason why. So I've stolen this from the Backbone Geppetto framework. And what they've done is actually a really interesting job of of breaking down all the interactions that happen on the client. So you don't actually have to understand this, but I just think it's a nice way of expressing the complexity that we have to deal with on the front end. We're dealing with data that's changing maybe on the client, but also the server. And when those things collide, we have to understand how things changed. And when they break, we want to understand what changed them, what broke them. So Flux is trying to take something like this and turn it into this, which I'm not sure if your brain is like mine, but my brain loves that image a lot more. There's less arrows. And both of those approaches are really just trying to deal with some core problems that we have on the front end. Namely, that change is hard to reason about. So when data enters our application, there's that beautiful moment when you grab your JSON payload, you render it out into a view, and you're like, yes, a list of items, to-dos, yes, I've achieved everything that I can dream about as an engineer. But then, of course, your user is going to want to update that list. Or maybe the server, someone else, another user has updated that list on the server, and you want to re-render those changes. And trying to debug and track down what changed that when you have multiple components that are dealing with that same data can actually be rather difficult sometimes. So it's complex, and it's hard to understand, especially if you're trying to debug it when you've deployed and something's broken. You want to know why it changed, when it changed, and who changed it. And if multiple things can change that, that makes your debugging process a lot more difficult. This leads to difficulty in restructuring your components as well. If multiple things can change your data or change your view, adding on new components means that you might have to redo your entire architecture for communicating between components when you scale your app. And that's not something that you want to do under a deadline or under a stressful situation like debugging, for example. So you want to simplify the way that components can communicate, so you can just add new ones on whenever you want. Finally, onboarding gets more difficult. I've experienced a situation where you have several different components talking together, and it's this weird step where component A talks to component B, but then component Z picks up an event and changes the data. And it's not always clear communicating that to someone new that that's actually what happens. They just kind of have to know, well, really, it's this series of events that lead to that changing. And you want to have something that's very simple for them to understand, so they can just see A, B, C, instead of this weird kind of evented system that we get into when we scale. And the awful truth is that Flux doesn't really solve these problems, but it's going to make them easier to reason about. And that's, I think, the best that we can do, is just trying to simplify the complexities. We can't make them go away. And it's going to do that by providing a pipeline for change. So like in the image that we saw earlier, it's this simple flow from one end of this pipe to the other, instead of these multiple arrows that are kind of looping around on themselves. And it's just easier to understand. It also is going to give us some basic building blocks at scale. So Flux is going to break down the change in your application into several discrete steps that are all owned by different components within Flux. And that just makes it easier to debug and reason about. You can kind of observe the change as it flows through your application. It also provides a simple philosophy for change. And I think that this can't be overstated. It's often understated. The reason why I think I get excited about Flux is that it's an idea that's easy to communicate, and it's something that I can get excited about, which is the reason that I'm giving this talk. I think sometimes you find a new framework or a new idea and you bring it to your team, and it's more about the bullet points of what it can enable us to do. Oh, two-way data binding in Angular, for example. This is great. But really, the underlying concepts are what excite you and make you want to implement it. So with Flux, it's a simple but I think resounding truth that we want to simplify the way we manage data. And so I can get excited about that and talk about it with my teammates in a way that I couldn't when it's just a kind of a spec feature on some framework's web page. And I think that's just cool. It's great. Another reason is that it just sounds cooler than saying MVC. So I'm really tired of saying MVC and MVC star, so Flux is a nice change. Let's get into the core of Flux. And that's really just this, unidirectional data. Here we just have an action that triggers a change in our data that flows into the view, which triggers an action and starts the cycle over again. And it's just about repeating this pattern throughout your app. So you can just understand how your data is changing, and you don't have to go through multiple layers of evented components. You can just understand this one flow. So we can play that. Over that flow, we'll play the actual Flux components. We have actions, dispatchers, stores, and views. Again, just one-way flow and loops back in on itself. So we'll talk about the first component in that step, and that's just an action. These are the catalysts of the data flow. So this is how data from the server, whether that's pulling from an XHR or an event, enters your application, or a client action, say clicking a button. These are dispatched to any store in your application. So any component that deals with change, with holding state, is always notified when an action is triggered. Even if it's not something that it's necessarily interested in holding on to, it's always aware of any changes. And actions look like this. It's just a simple object, usually with a type, which identifies it to anyone interested. So things that are interested in dealing with comments are probably going to want to know that this deals with comments, so they can grab the data off of it. And it's also going to contain some data. And I like to nest mine underneath a data property, but these could easily live at the top level of this object if you wanted to. I'm going to drink some more water because I'm bad at pausing. And they can be triggered by the client, as I said before. So here we have a button click that's going to create an action. Or by the server on a WebSocket connection, or perhaps you're pulling with an XHR to see if data is updated. That could trigger an action too. So it gives you kind of one way to have data enter in instead of having to deal with these weird interfaces between the client and the server. It just dispatches an action, and that's going to change your data and re-render your view. So we can go into the dispatcher. These are the heart of this is the heart of the Flux application. They're usually a singleton, so there's just going to be one for the lifecycle of your app. They're going to publish all actions to all the stores in your application. And they're also going to help manage the dependencies between stores. So perhaps we have a comment store and a user store. And a comment store needs data from the user store to re-render itself properly or update itself properly. It can use the dispatcher to say, hey, please don't invoke my callback until the user store is updated. And in that way, your stores can have dependencies, and your data can always re-render when it has the most current data that it needs. So it gives you just a really neat way to make sure that when you change your application, it's always ordered and predictable. Next, we have the store. These are the source of truth for all the facets of your application. And that's kind of a complicated way of saying you can break up the different parts of state that you need to hold into stores. So you might have a user store just to hold all the users. And that would be kind of a similar model that you'd use on the server with a user model, maybe in an ORM. But you also might have online users. And that's going to actually just hold a list of users that have the online attribute set to true, perhaps. So you can kind of atomically break up the different parts of your application into stores. They don't have to be a model per se. It could just be page state. So maybe you're transitioning a view in. You have a transition store to manage how your views are transitioning in and out of your application. Or any other thing that you just kind of want to have control over the change of that piece of data. They're going to interpret and all dispatches and then update themselves accordingly. So as we saw earlier with the type that we added to the data, the user store is probably going to care when we add a user or we remove a user, but perhaps there are other payloads that involve changing users. The user store can listen to all dispatches and interpret them and update itself. Externally, stores are read-only, so nothing writes to a store except the store itself. They do write to themselves when actions are dispatched. So you can trigger an action that will update a store, but no one actually writes to the store. It's the only one that can control that data. And that just makes things nice, because I've had an issue where, say, using Backbone, I've written to views or written to models from a view, and when you do that multiple times, it gets a little crazy and frustrating. So this just makes it very predictable. It also is going to notify any subscribing views that it's changed. So your view definitely wants to re-render when your model's changed, and the store helps you do that. Finally, the view. These are going to subscribe to stores, so they can easily re-render when the store changes. They're going to trigger action creation, so by exposing UI components to your user, that'll trigger an action that'll actually change your data. And the best way to think about this, I think, is to have data flow from a topmost controller view. So this is something that React has promoted, where you have one top-level component. In Angular, this might be just a controller that's going to query the different stores that it needs for the data, listen to them for changes, and then pass that data down to child components. And ideally, it's just components all the way down. That way, you can have one top-level thing that's having to worry about the state of data, and every other child component is simply just a dumb piece of your application that can be mixed and matched anywhere. And that's essentially it, is just repeating this pattern. So using these components to break up the pipeline of your data, you can just scale your application from really small prototype to actually working by using the same components over and over again, just allowing you the change and control, or the control over change that you need. So we can get into an example now. One of the things that I struggle with as a developer is just dealing with all of the information that we have to pick up every single day. And to that end, I've been trying to create a discipline of just recording the things that I learn. So I wrote a small command line utility to just add things to a list. And at the end of the day, I try to review it to just see, what did I actually do today? Because often I'll ask myself that question, or a friend will ask me, what'd you do? And I have no idea. So let's build an application that can just allow us to record the things that we learn, which we'll call TILs. I'll say that a lot. I'm sorry if that is an annoying phrase. And then we're going to comment on them with our friends. So for the setup, we're going to use Angular because it's popular, it's fast, it has a solid service core, and it's not React. And I say that not because I don't like React, actually. It's great. It's some of the most fun I've had writing JavaScript recently. But often Flux and React are paired together. And that's a really great match, but it's totally, you can use Flux with any framework. Anything that will allow you to re-render your view when your data changes efficiently is a great fit. So Angular is good, Ember is good. You could use Backbone with rivets or another like two-way data binding plugin. Anything that can re-render efficiently is a great fit for Flux. So for some assumptions, we're going to use Browserify and CommonJS for our front-end code. This shouldn't get in your way too much, but I just wanted to give you a heads up if you see a require and it seems kind of funky. We write JavaScript like that at Braintree, so if you want to talk about more on that subject, I'd love to talk about it with you, because we've really found a lot of value in both of those tools. And then finally, we're not going to actually build a backend, but you can imagine an Express and Mongo backend backing this application. So if something seems very NoSQL-y, that's why. The code is going to be available here on my GitHub, and I believe that's actually there. Wow, props to me. And we'll be stepping through certain branches in the repo if you want to follow along with me. That's totally not required, but feel free to grab that if you're interested. So we can start simple. You can check out step 1 here, and this is going to have the completed code for this next step if you want to. I'll give you a second to do that. And I'm actually going to use a video now because I do not trust my brain or my fingers to type this out properly. Cool. So we'll start here. Here's our just view for the application. This is the template that's rendering it out. So we have a single HTML file here with a form, an input, and then an area that we're going to list all the things that we've learned. Right now, it's just static. So go ahead and open up our application file. Oh, did that not render? All right, never mind. 1 second. Yeah. OK, yay. All right, so this is our static view. And here's the template that's rendering that. So we have a form, an input, and then an area where we'll list the things that we've learned. Great. So go to our application file. And we'll record some of the things that we'll require some of the modules that we need for application. So of course, we'll need Angular. Then we'll grab the dispatcher from the Flux module that Facebook has published. This is the most vanilla implementation you can get. We'll also grab event emitter, which we'll use in our stores to just dispatch events on themselves. And finally, we'll grab the UUID module. So we can have a unique identifier on the client side, and that'll allow our views to update themselves quickly. Great. So we created an Angular application with a controller. We'll just call index for simplicity. And then here, a thing to note, if you're not familiar with Angular, scope is the kind of globally shared object that Angular is constantly watching for changes. So you start with the top level, root scope of your application, and then everything that implements another scope has a reference to that same object. So the properties that we add to scope in our controller, whether they're methods or just flat properties, are going to be available to anything underneath this controller. So any component that we add underneath this controller is going to have access to the same things. So we'll go ahead and add a list of items, which we'll just add a simple item here to make sure that we're binding to our view properly. And then we'll add a method that'll just allow us to add an item to that list. We do a little bit of logging here to make sure that we've actually done our job properly. This is going to be a reference to an input that we'll add in our template later on, and I'll just set it to a blank string just to indicate that's actually what we're doing. Cool. So we can go to our template now, and we'll call that method that we added when our form is submitted. So this will allow us to grab the value of the input, and we'll bind that input to that value that we saw in our controller earlier. Finally, we'll loop over the list of items that we created, and then we'll just display the text for each one. Great. So we can actually go back to the browser and see that this worked. Hopefully it did. And yes, we've made it through the controller. So that logging that we saw earlier has worked. We can now go ahead and make things more dynamic. So before we create any sort of Flux components, we do need to instantiate a dispatcher. And now we'll actually just create an action creator service that will allow us to dispatch actions. We had an add TIL method to that takes some text in. We'll do some more logging just to give us ourselves some nice feedback. And then we'll dispatch an action. And that's just going to be a simple object with a type of add TIL. And then underneath that, we'll nest a data object with the TIL itself. We can go back to our controller, require that service, and then in the method that we added to scope, we'll just call it with the value of the input at this time. Great. So we can see we've logged out both in that controller's method and now in our action. So we can go ahead and start implementing a store here to persist this on the client end. In the store, we'll have a flat list of objects. They'll just contain all the things that we've learned. And I think here it's important to note that this is just a simple JavaScript object. While the store is functioning as a model, it doesn't have the powers of, say, a backbone model or another like Ember's models or collections. We're just dealing with the simple, basic JavaScript objects that we know and love, maybe. And I think that is a really nice way of handling things, because sometimes we can over-architect, and we have these powerful models running around when we don't really need the features that they need. This allows us to create really simple, discrete stores that can do just what they need to do, instead of having all of these features that we don't actually use. And it's easier to just onboard someone else because they don't have to know all these custom methods for the model. They can just use and iterate over these collections like they would with any other flat JavaScript objects. So here we're going to play the event emitter prototype over an object, and we're going to add some methods to it to allow people to subscribe to this view. So add change listener just takes a callback, and when our store changes, we're going to invoke that callback. And we can do that since the store is going to have all the properties that the event emitter has. Now we're going to add a simple helper method to return all the TILs in our object as an array for easy iteration if we want to use them later on. And then we'll register with the dispatcher. So this is going to mean that every time any action is dispatched, our store's callback is going to be called. Here we'll use a switch statement on the payload's type just to see if it's something that we're interested in. And in this case, we're really only interested in when we add TILs. We'll grab the TIL off the payload, give it a unique client ID. So this way our view can just re-render and know it's the exact item that it needs and not actually have to create a new DOM node. And then we'll add that TIL based on the client ID to that list of objects that we had earlier. Sure. Sorry, let me pause. Yeah, go for it. Mm-hmm.
So is this store actually going to save it in a local?
No, it's just going to be in memory. Yeah. It could if you wanted to, which would be a great way of kind of handling recovery if an application bails on you. But right now we're just going to kind of keep it we're actually just going to store it in memory. Okay. Yeah. Cool. So here we're going to add a default case to make our linter happy. That's going to do absolutely nothing. And then we actually just return the store so we can require it in our controller. We can go ahead and do that right now. So here we'll use the add change listener method that we added earlier to just update our list of TILs when the store changes. And we'll just reassign it to the value of the getAll helper method that we created earlier. So going back to our browser, fingers crossed, you can see that, yes, we've updated and persisted our view. So this is actually the full Flux cycle in a nutshell. That's all that you really need to do. There's obviously a lot more complexity in terms of the business logic of your application around that, but that's the pipeline in one file. And one of the things that I found difficult when I was learning this pattern was, for good reason, most people split this up into multiple files. They have a directory for stores, they have a directory for actions, but it can be hard to visualize how that change happens in your application if you're having to open 6 files at once to understand it. So I found it helpful for myself. I only really got Flux when I wrote it all in one file. And so if you're communicating to new people, that might be a good approach to take too. Great. So now let's componentize. If you're following along with Git, you can do git checkout step 2. But I think that one of the benefits of Flux is when you're architecting your application, it gives you control over your data, but also that control allows you to create these really discrete components that can just act on the data that they need instead of having to know about models or different collections. So the structure that we're aiming for is something like this. We have a top-level controller view, which is going to be like our index controller that we saw earlier, or it's just another directive or component in your stack. And that's going to gather the data. So right now, since we're concerned with TILs, that's going to query a TIL store or any other stores that we need and gather that data and then just pass it down to its children as an attribute. So here we have a TIL list. We can break that just hard-coded template we had earlier into its own separate component. This could be an Angular directive, a React component, a backbone module. It doesn't really matter. But all it cares about is the things that it gets through that TIL's attribute. So that just limits the scope, both in terms of Angular and just the word used generally, that this component needs to worry about. And we can break that input that's creating our TILs into its own separate component as well. And this doesn't need to know about anything. It's completely unaffected by the state of data at the top level. All it needs to do is trigger an action that creates a TIL. This leads to the ability to compose pages and subpages of just simple components. We don't have to have all these dependencies between where a component is placed. As long as it's placed somewhere in a stack of components that has access to the data it needs, it can be mixed and matched anywhere. And it just pushes that responsibility for maintaining the state of your data up the stack to controllers, where it really should be. The thing that I like about this is when you're working with a designer or a teammate that's new to your project, you can just say, this thing just needs a list of this data. And maybe you've already provided that data for them somewhere else up above their view, and they can just reuse these simple components anywhere. Or you need to reuse this add TIL component in another page on your view. You can do that very easily. It just makes the process of building things out a lot faster, so you can just iterate quicker. Great, so let's actually look at some code here. This is what that TIL list component would look like. And this is an Angular directive, which is something that Angular uses to bind JavaScript, code logic functionality to a DOM node. And so within this, we're returning an object with a scope property. And all that says is, Angular, when this attribute of mine changes, make sure that I re-render. Normally, all components get all of the things on their parent scope. By declaring it like this, we can limit the visibility that this component has. So it's only going to worry about this one thing. which makes it just a lot easier to reuse and also easier to not mess up your application by accidentally modifying scope. And then we just pass it a template URL. And the template looks a lot like the HTML that we had in our file earlier. We're simply looping over that list of TILs, and then we're printing out the text for each one. And in the wild, this is how it would look. We might have any containing elements, and then we just have our TIL list element and TILs attribute. And we probably attach that at some level on scope in the parent. This is our input component, so add TIL. Our scope is empty here because this cares about nothing, which is great. The template is simple enough to keep inline, so we just have an input that calls a method add TIL whenever it's the key up event is fired on it. And then in our link function, we're just going to check, was the key pressed enter? If so, we dispatch a client action, or we create a client action. And then that's the use case right there. Just a simple add TIL component that we can put anywhere in our view. Altogether, we have our controller, which is going to gather the data. We have our add TIL component, and then we have our TIL list below that. I really like thinking about components like this. It's one of the things I think that Angular enables us to do really well, and also React. So you have these easily composable elements that are simple to understand because they're very declarative, and you can just mix and match them throughout your views as you go. So this is just that working. Great. So we've just split things out now. They're more manageable. It's not all in one file, and it's actually working. Huzzah. So let's add some additional stores to our application. You can git checkout step 3 if you want to follow along. Here's our imaginary backend. We have an API route with a user resource and a TIL resource. And when we call them with an XHR, we get a payload like this. At the top level, we have users. Below that, we have TILs. You can see under there, we have a user ID property, which just refers to the users in the user object. And Flux doesn't impose any structure on the way that you serve your data, but I find that this is the most helpful pattern. Because multiple stores might want to know about this data, say the user store, but also the TIL store. Nesting things at the top level allows those stores to easily pluck the objects off that they care about without having to go descend through some really gross nested JSON. You don't have to do this. You can actually do this on the client side by pulling that out and normalizing the data and then passing it to the store. But I find it helpful to just have the backend return this. It just makes our job easier on the client side. And this is that server-side action that we would use. So we get the data from our XHR, and then we just dispatch it with the TILs and the users from that data on the data property of the action. So now we do need to create a user store to hold our user data. This looks very similar to the user store or the TIL store we created earlier, except there's one major difference. Here we're actually assigning the result of registering with the dispatcher to the store. And all that does is it gives it a unique token that can be used by other stores that want to wait for this store to update. So they can pass that to the dispatcher and only update themselves when that store is actually updated. Again, we'll just use a switch on the payload type, and we'll just loop over each of the users on that payload and then change. Those methods look like this. We simply assign the user's ID to the user object that we get, and then we grab a user by their ID. So that allows us to just easily assign and retrieve users. Finally, we'll update our TIL store. And here we're going to actually use that wait for method. So we've required the user store. We have access to that token. And we're going to tell the dispatcher to please wait for that user store to update before continuing with my callback. Then we emit our change event. And here, since we have to deal with user data now, we're going to actually grab the user from the user store, assign it to the TIL, and then update our internal list of TILs. So that is this in action. Yes, so we've made it through. We've actually have users assigned to TILs at the moment. So let's add one more layer. We'll add comments to our application. You can git check out step 4 if you want to follow along. This is our updated API. We still have the user and TIL endpoints, but we're going to actually include comments underneath the TIL. And the payload is going to look like this. The same as we had before. We have users, we have TILs, but underneath TILs, we'll add some comments. And this is a design decision that I've made. Again, Flux is not imposing anything, but I find it easier to actually nest the comments underneath TILs for application at this state. We don't really need TILs outside of the context, or comments outside of the context of TILs at the moment. And since we're using Mongo, the ability to embed documents comes in handy right here. You don't have to do this, but I think that it just shows how Flux enables you to make the calls that you want. So your data can be structured however is best for your application. There's no structure imposed here. So to look again at our components, we still have a controller view. We have our TIL list. And then underneath that, we're just going to nest a comment list. And this will be this component will be booted up for every single TIL in this list, because every single TIL is going to have a list of comments. And that component looks like this. We, again, just create an Angular directive. We only want to bind to the single TIL that this comment list is for on scope. And then we have an add comment method there. That's just going to do the same checking for enter that we did earlier, and then create a client action with the value of the comment, the client ID of the TIL, so we can actually identify it and update it, and then the user ID that I've just hard-coded here. And the template for a component looks like this. We have a header. We loop over the comments on the TIL and display the text and the user. And then below, we have an input that adds comment. You could break this out into smaller components if you need to, but right now, it's self-contained enough that it can all live here. Finally, we have our action, which just adds a comment, and then we grab the data from our component earlier. And then in our TIL store, we again wait for the user store, and then we add comments for the comment on the data payload that we had. And that just looks like this. We grab the TIL from the client ID that we assigned earlier. We grab the user from the user store, because every comment does have a user. And then we add that comment to the list of comments on the TIL. And again, here it is in action. Cool. So there. So now, what have we done? We've explored the Flux pipeline. We've created some powerful discrete components. And we've made ordered changes to our data with store dependencies. So obviously, this is a very trivial application. We haven't gotten into a lot of super complex stuff here. But hopefully, this gives you a taste for the control that you'd have with Flux. Some cool things is from the pipeline that you can do is you can actually start recording these actions and playing them back. So if you wanted to see how a client, or rather a user, got themselves into trouble, you could actually be logging these actions and then trying to replay them later on to debug them. So it might seem like a lot of structure to impose just on simple changes, but the more complex things get, you actually want those kind of breakpoints built into the structure of your data. I think that it's like a very interesting concept to start doing this in the same way that we would want to log queries for a database and replay them. You could maybe pick up on actions if a client drops out. You have that log, both for debugging, but also for disaster recovery. So it opens up a lot of interesting possibilities on the front end. So the future of Flux really is frameworks. You can see there's already a lot of kind of boilerplate that we've had to do today. I've omitted some of it from the slides, but I think a lot of the advantages come from actually using a framework that's going to give you the core of Flux with some niceties. So there are many. The ones listed here are just a few. I picked them mostly just because they have Back to the Future related names, which is fantastic. But I'd suggest starting with the default Flux implementation that is going to be in the Flux docs, and then comparing and contrasting it with these different frameworks. Some of them are just going to provide some simple helpers for you. Others are going to tweak the actual core elements. So I particularly like Fluxer. It's more closer to the default Flux with some just interesting helpers, but Marty.js is another one that's really interesting. So I'd suggest maybe starting with those two after you've done the default Flux stuff. Finally, here's some not so fun stuff about Flux. There's a large mental footprint initially. So like I talked about, just visualizing change can be difficult. It does mean that I think initially onboarding people can be a little bit strange if they're not used to the pattern. But once they see just the core elements, it's easier to communicate, and then it's easy to kind of get into the flow. There is some boilerplate involved. So the store code obviously is a little gross. Nobody really likes switch statements. I don't personally. So you can reduce that very easily with helpers or by using a framework, but you are going to have to do that work yourself or go out and find someone who's done it for you. It's BYO everything. So Flux is only going to provide those elements to create that pipeline. It's not going to give you services. It's not going to give you anything else you need to actually build a front-end application. And that's bad, but it's also kind of wonderful because often I find myself needing to rip out parts of a framework or just discard and not use. And in this way, you kind of get to bring everything that you want to the table. And Flux just gives you that ability to control how your data is changing. There's also, unfortunately, no clear conventions. This is also good and bad because you can kind of write your own, but sometimes I like to be told, this is the right way to do something, this is the wrong way to do something. And with Flux, there's many different opinions on what the right way is. You can see this on Google Groups or like Stack Overflow questions. There'll be people arguing the creators of Flux will have one opinion, and then other people, like framework writers, will have another. And so it's interesting to have that kind of mental conflict between what do I actually do? And that's just something that I think we all have to navigate. I do like the fact that it's more of an interpretation. So you're free to kind of impose whatever structure you want on it. Finally, here are some resources. I'm not actually going to go into them, but I wanted to highlight the Flux documentation. And then the third item, Yahoo's Flux examples. They're quite interesting. So Yahoo's been using it and tweaking Flux for a while. And that repo provides some really interesting ideas that they've done. So that's really all that I have. Thank you. There's the joined in links here. If you want to give me some feedback, I'd really appreciate it. And I think we actually we have a little bit of time for questions. So I'm free to take those now.
Well, you kind of answered it with the last slide, but I thought it was interesting that you used Angular as an example. In the real world, does anyone use Flux without React? Because it seems like React really lends itself well to it, but Angular, seems like you're kind of fighting against Angular.
Yeah, a little bit. So in the actual implementation, like one of the things that I unfortunately had to do is because the store cycle happens outside of the normal digest cycle, you have to actually wrap like updates in timeout to have them consistently render. So like $timeout. But other than that, honestly, it hasn't been that bad. I think the idea of like limiting scope for Directive is a practice that's already in place for a lot of ways and is preferred. So that is not a huge tweak. We're starting to use, I've been working on an Angular application for the past few months, and we're starting to use some of these elements in there, and I haven't found it to be horrible. So I think that it just forces you down maybe one particular path with Angular, but it hasn't been that bad. Yeah, and I think with Angular 2, it's going to be even better.
Yeah. We're using Polymer, and it's pretty, I don't have a lot of things.
Yeah.
I just wonder if this is even possible with something like Polymer.
Yeah, I haven't played around with Polymer. I'm really interested in it because initially I was like, oh, gross, like components. But now with React, I think it's a really good paradigm. Mm-hmm. So I'm not sure how easy it would be to do with Polymer, but you might be able to do it.
You can do it with Angular, but
yeah. Sure. Cool. Well, if anyone doesn't have any other questions, we can end early.